we're going to start going through the in-class examples for the first part of 7.3. So the first question says, below is a table containing the number of calories per serving for 16 brands of frozen cheese pizza. Find the 5-number summary for the list above. What's the 5-number summary again? It's the quartiles, so Q0, Q1, Q2, Q3, Q4, and Q5. Who remembers how to do that? Enter your data into the calculator and do the one variable stat on it. Why don't you practice doing that right now? Stat button, edit, type the data into one of those lists, whichever list you choose. Then you'll exit out of there and do stat calc, one variable stat.
I was trying to do it, and like that's my set as a weird thing, so it's not like it went here. Let's do this.
If there's 2, 3, 40, they're putting in 12.
So when you remember to clear a list, you use clear and then down. You don't press the delete button. But those are all your lists back. And now it should do probably what you're hoping it to do.
Yeah.
Cool? This is all one data set. So all those numbers go into one list. When I did this, I put mine all into the list L1. Okay, if you have your data in, what do we do next? Second, quit, and then stat, calc, one variable stats, L1, no frequency list though, because it's just a single data list.
How would I type this L1?
You do second and the number 1. Look above the numbers 1, 2, 3, 4, 5, 6. In blue is L1, L2, L3, L4, etc. Yep, and if you scroll down, minimum is Q0, Q1 is listed there, median is Q2, Q3 is listed, maximum is Q4, so you literally just write down what it comes out of your calculator. This is the story of first semester. It's all pretty easy if you know how to get it out of your calculator. All right. Who can do it for realsies? Give me that 5-number summary for the next data set. You may not want to clear that first data set because I think it comes up again. It's fine. You can just type it over again. Reese is like, now you tell me. Sorry, dude. Them's the breaks. This group of 15 IB Math SL students needs to slow down.
So what's the, it's like Q1.
So min is Q0. Q1 is Q1. Median is Q2. Q3 is given, and Q4 is max.
Yes.
God.
So Q0 is 0, then we have 1, 2, 4, and 9 respectively. Everybody cool with how we got those?
Just like the last five always is the.
That's the 5-number summaries, those last 5, yep. Everybody cool? Pretty easy. All right, calculate the mean for the pizzas.
I'm trying to, you know how to do it? We do have to be put at the table. For a while. Not like within the key one thing. Second, quit. Stat. Calculate. L1. If it was in L1. What is it? What? Oh, yeah.
I was expecting
Who got 328.75? Yeah. What's up? So look above the numbers 1, 2, 3, 4, 5, 6 is in blue, L1, L2, L3, L4, etc. So you just do second number 2 or whatever.
That's cool. Where is it? The mean shows up in this.
X bar is the abbreviation for mean.
X bar.
Yep.
Oh.
Which I think is the first thing that's listed there.
Oh, the X, the line up there.
Yep. That's what we read as X bar. That's our symbol for mean. So again, pretty nice, right? Thank you, Mr. Calculator. Everybody's cool? All right, try the next one. Here you get a frequency table. Ooh, scary.
To clear a list.
You highlight the name of it, like you put your cursor up on L1, then you press clear and then down.
Does this mean I do like 2 lists?
Yes, you'd use 2 lists to do this. Very good, Allie.
Clearing the arrow.
Then the down arrow,
Yes.
Got it.
and it wipes the whole thing for you.
Oh, wait. Would it be 2 variables?
Nope. Still 1 variable, but this time you're going to use a frequency list. Because the table you have has frequencies in it. Yeah.
So would you do like L2 under frequency?
If that's where you put your frequencies, yeah. I got 2.8.
Is it 2 variables?
Nope, still 1 variable.
What did we wrong?
Yeah, so your second list where the frequencies are, the 2, 6, 5, 7, 5, 3, 2 list, that needs to be under the frequency list when you do a 1 variable stat. So you probably did L1 and then L2 as your frequency list.
I put all. That's a difference.
Oh, no, you gotta clear them both.
So L1 is one, L2 is the other.
Wherever you want to put them, it doesn't matter the names, as long as you tell when you tell it to do the stats, you tell it where to look for the data. You could have it in I had mine in L3 and L4 because I've went and preloaded all the data so I didn't have to type it in real time. So you got 2.8, right? It's going okay? Let's work on the next one.
I like this math.
Oh no. What would I put into L1? It's a range of values. What do I do with that?
Middle.
what's its name though?
Yeah, I don't.
The mid
Point.
interval value, which is just the middle of like 65 to 69. So you have to use a mid interval value here, just like you did in the worksheet. Remember doing that? Yesterday we did mid interval value? Yeah. So instead of 65 to 69, you're just going to use the mid interval value, which would be 67. And then you do it the same way as the previous one after that. Because again, you have frequencies. So I got 86.375. Nice. It's going okay. Figuring out the calculator. Super helpful. Calculator's your best friend. Make sure you take it out to dinner, pull out its chair, order it something nice, really get acquainted. You know, bring it flowers the next day, you know. Laugh at all of its stories. Tell the calculator its hair looks nice. Okay, let's try the next one. Oh no! What do I do with this? Same thing, mid-interval values, yeah! Sure, like 0.5s. Like totally. Well, can't remember what my lettering I used here. Okay. Dang it. Dang it. There we go. What am I doing? Oh, okay. It's because I named my lists because I want to put all the data sets in here without having to delete and like retype it in real time. I named once I got past 6, I started naming my list and I was trying to find where the name is. I just named them like A, B, C, D, etc. But I can't use the letter A, I have to use the list A. So I had to figure out where I had to find the list variable at. That's where I was like hunting. Should have looked at the list menu instead of the variables menu. Yeah. Anyways, should have got 14 for this one. Did you guys get 14? Nice. Nice. What would the mode or modal class be for this example 6? The mode or modal class. Yeah, 13 to 14 would be the modal class, right? Since it's not a single value, it's a class of values. And you can tell just because it has the highest frequency. How about for this one? What's the mode or modal class? 90 to 94 is the modal class. How about for this one? 3 is the mode, right? Everybody feel good? That's easy stuff. All right. Below is a table containing the amount of fat in grams for chicken sandwiches or fish sandwiches at McDonald's. Oh my God, what did I do? I wrote in this thing. I shouldn't have been writing in this thing. Make a well-labeled stem plot for the information above. So what are my stems going to be? You did it yesterday on the worksheet.
That's the one that's split. Yeah.
Well, it doesn't say a split stem and leaf plot
That's
or
one I
back to
was-
back, but it looks like, yeah, still a stem plot. What are the numbers for the stem going to be? Look at the tens places on the numbers in the table. 0, 1, 2, 3. Excellent. Right? Because we have something with no 10 spot. That's why we need the 0.
Oh, yeah.
So what would go on the 0 stem? 9. What would go on the 1 stem? Is that the right order, though? What's the order it has it to be in? So 4, 6, 9, 9, right? Everybody feel good about how to do that? You remember doing it yesterday? It's not too hard. Find the mean amount of fat.
Which one's the label for median?
Well, if you scroll down, it says MED for median. It smells fishy to me. Not just because we're talking about fish sandwiches. Did I miss one? No, okay. Oops. Okay. It says here, the premium chicken club sandwich is a potential outlier. How much does this one sandwich change the mean and the median? So we saw that included the mean was 19.9 and the median was 19, right? So let's go to our data list and we're going to just delete out that one premium crispy chicken club sandwich. That's a lot of names. So I'm just going to delete out that one value. Yep. Use the delete button. And then if I rerun my analysis, well, my mean has decreased to 18.25. but my median remains the same at 19. What are we illustrating here? That the potential outlier affects the mean much more than the median. In this case, that outlier didn't affect the median at all. Which way will the mean be pulled by an outlier? Toward that outlier. So the mean is pulled to the right. It increased when we added in that 33, right? That's it for this stuff. You guys feel okay on that? Feel better about using your calculator? Cool. Let's do the next piece of section 7.3, and that'll wrap up chapter 7 for us. So here we're going to be talking about spread, or yes, sir. Yeah, go ahead. Or dispersion. Dispersion and spread kind of mean the same thing. So it's a description of like how uniform the data is. Like it's a numerical description of how close that data is to its center. So one measurement is called the range. To calculate the range, we just arrange the observations in increasing order. We find the minimum value, we find the maximum value, and we subtract them. That's it. Does the calculator give you the minimum and maximum values for us? It does. Will you have to subtract them on your own? Unfortunately, yes. You'll have to do that on your own, which I know is pretty rough. You're right, yes. But the calculator just doesn't output it for you. You actually have to go and go, what was that number? Oh, man. Now, we've talked a little bit about outliers a couple of times. What we want to do now is formalize how we can tell if a data point is an outlier. So to do that, we're going to use something called the interquartile range, which we abbreviate as IQR. I will use that abbreviation without the name all the time. So you need to know what that abbreviation stands for and what to do when you see it. So to calculate the IQR, we need to first find my quartiles. That's the 5-number summary. How would we do that in practice? The calculator. Let the calculator do it. So again, we arrange the observations in order, locate the median. The first quartile is the median of the observations to the left of the median, and the third quartile is the median observations to the right. So the interquartile range is just the difference of Q3 and Q1. Again, does the calculator give you Q3? Does it give you Q1? Do you have to do the subtraction on your own? Yeah. Okay. So I'm going to use that interquartile range to determine if a data point is an outlier or not. Let's look at how we do that. Well, I guess we're going to do an example first. So here's our friendly commute times for New Yorkers. So we'll arrange it from smallest to biggest. We'll identify the median, which was the midpoint between 20 and 25. And then we'll find the Q1 and Q3, which again is the middle of these guys. And so it would be 27.5, right? The nice part is the calculator will give you everything that we really need out of this. All you got to do is the subtraction, right? In practice, we probably wouldn't do this by hand because yuckarooskies. It's like a hassle to arrange data from smallest to biggest. Like that really stinks. So to determine if a value is an outlier, we can use the 1.5 times the IQR. So if an observation falls more than 1.5 times the IQR, either above the third quartile or below the first quartile, we will classify those observations as outliers. That is something that you'll need to remember. So 1.5 times the IQR above Q3 or below Q1 will indicate an outlier. So returning to that previous example, Q1 was 15 and Q3 was 42.5 and our IQR was 27.5. So if I do 1.5 times the IQR, I get 41.25. So if I take my Q1 and subtract that 1.5 times the IQR, I get negative 26.25. Well, clearly there's no outlier on the low end of commute times because time can't be negative, right? Okay, great. If I do Q3 plus 1.5 times IQR, I get 83.75. So anything bigger than that would consider an outlier above, like an upper outlier. And I noticed that if I looked at my data, there was one person at an 85-minute commute. That poor sucker is an outlier since it is bigger than 1.5 times IQR plus Q3. Is that okay? Will I ask you to do this on quizzes and tests? Oh, you betcha. Okay. So again, for a 5-number summary, or we've talked about this again, I don't know why it's in here again. It's the minimum or Q0, Q1, the median or Q2, Q3, and the maximum or Q4. A new type of plot, a new type of graph that we can make with the 5-number summary is called the box plot, or box and whisker plot sometimes it's called. So we start by drawing a box from the first quartile to the third quartile. The observations are just labeled on the x-axis, right? So we just have an x-axis. We mark a line in the middle of that box for the median, and then we draw a line from the end, each end of the box to the minimum and maximum. We call those lines the whiskers, provided that those are not outliers, right? The whiskers don't go all the way to the outlier. It goes to the biggest acceptable value or smallest acceptable value. Outliers we mark with a special symbol, so like you just plot like an asterisk. Let's look at a picture here of doing that. So here's our New York travel time data. Our 5-number summary told us all of this information, right? Remember, the 85 was an outlier. So on my x-axis, I labeled just numbers, and I called this travel time. Probably should have this in minutes or something. Give a unit on that too would be better. So I'm going to draw my box. So it's going to start at 15 and end at 42.5. And then the middle of at 22.5, I'm going to have a second line. So there's the box. Very cool with how I constructed the box. Doesn't matter how tall the box is. No, man, there's no y-axis. Now I'll draw my whisker. So my minimum goes to 5. So there's my left whisker. On my right whisker, the minimum non-outlier is 65. So it goes to 65. And then I need to mark my outlier with like an asterisk or something. There at 85. So that's what like my box and whisker looks like. No big deal, right? If I got the 5-number summary, it's pretty easy to draw this. Everybody's cool? Just got to remember what to do, though. You know what I mean?
Would the outlier be like the fifth number?
5-number summary.
Yeah.
Your outlier could be, it could also be a number that's not. You could have multiple outliers, right? So if you had 2 big outliers, only one of them is going to be the max. You know, like if I had 84 and 85 in there, both of those would be outliers, but only one of them was a max. Does that make sense?
Yeah.
So it doesn't have to be. Oftentimes it will be.
Is the asterisk on the outlier or the?
On any outliers.
Any outlier?
Yeah, any outliers. Not just because it's the max, because it's the outlier in this example. If that was not an outlier, my whisker would just go all the way to 85, and I'd have no asterisk at all, no mark for an outlier. Which is often the case, right? All right. Another measurement of spread is called standard deviation. And basically that is looking at the average distance from each data point to the mean. So let's show an example of kind of what we mean by that. So here's a dot plot for the data on the number of pets owned by a group of 9 children. This person, I feel bad for their dad who's taking care of 9 pets here. Dads, you know who ends up taking care of the pets for the kids? It's your dad. So we need to start by calculating the mean. And then we need to calculate each deviation, i.e. the distance from that observation to the mean. So in our case, 5 was our mean. I calculated that for you guys. So this first deviation from this observation to the mean is -4. Because it's 4 units below the mean, right? I'm going to do that for every single data point. So this is me doing that deviation for every single data point. I'm then going to square each of these deviations because I really want to be looking at a distance, not, so this shouldn't be negative. So I'll square those. And then we're going to find the average of these squared deviations. If I look at just the sum of these, we call that the variance. Oh, I'm sorry, the sum of the squared, we call the variance. And then if we take the square root at the end, that's our standard deviation. Everybody's okay? We'll do this in practice a couple of times still here. So again, my average of the squared was the variance, that's 5.78. When I take the square root of that, that's my standard deviation, 2.40. So there's actually 2 different kinds of standard deviation. There's population and then sample standard deviation. In IB land, we're always going to be using population standard deviation, which is what's listed, what we're going to list here. So the difference between population and sample is that instead of n, you'd have n-1 for sample. But it's important that we're using the correct formula. I'll show you on the calculator how to do this though. Because in practice, we're not doing this by hand, right? So we have that. Yeah, and I just said the population is what this is. Okay. So we have these 2 different descriptors of spread. We have standard deviation and we have interquartile range. Typically, we use mean and standard deviation together, and we'd use median and interquartile range together. So the same rules that applied for mean and medians, when to use them, apply for standard deviation and interquartile range on when to use them. So again, mean for symmetric distributions. So standard deviation, great also for symmetric distribution. Median, good for skewed distribution. So IQR is also good on skewed distributions. Okay. What's going to happen if I say I'm doing collecting some data, say I'm collecting heights of students, and I'm sharing this with a collaborator from Europe, and my heights I collected in inches, and his heights he collected in meters, and we want to share our data together to do some kind of statistical analysis. What are we going to have to do? To convert so we're in a common unit, right? Either both of us, our measurements are going to have to be in inches, or both of them will have to be in meters, but we can't have some data in inches and some data in meters, right? What happens if I had already finished all of my statistics for my data that's in inches, and he had already finished all of his statistics for his data in meters? Do we have to redo everything, or is there like a conversion here that we can do? Yeah. So let's say, okay. So, well, I'm doing them. Let's take a separate example, get back to our conversion from feet to meters. Right? Let's say we're making a temperature conversion where we measured everything in Celsius, but oops, we actually want to give our data in kelvins. The conversion from Celsius to Kelvin is just adding 273. So what will that do to all of my measurements if I add 273? Well, it's going to change the center, our statistics for center by that same amount. So my mean would increase by 273. All of my 5-number summary increases by 273. But our measures of spread are going to remain the same, because if I think about the data, still in the same shape, it's just been moved to a new location, right? So none of my changes of dispersion or spread, none of those statistics changed. Everybody's okay with that? Again, this would be a very likely test question. So if I look at a visual example, say we have this data set, and I shift it by 13 units, you can see clearly that like the data is still the same spread apart, right? The shape is identical, it's just in a new location. Now the center of the data has changed, right?
Are we gonna have to like do the adding stuff or just say what it does?
Well, if I asked you, like if I gave you a mean and a standard deviation and asked you what the new mean and new standard deviation is, I could do that, right? Where all you have to do is add the shift to the mean, but not to the standard deviation. So like that, I would say is fair, but I don't think I'd make you like reset a data set, because that's just annoying. It's actually not bad to do in the calculator. You can just take like enter your raw data in L1, and then at the title of L2, you can type in L1 minus 10 or something, and it'll just whoop, fill it all in for you, which is pretty rad. We'll show you how to do that later. So there we go. Anyways, continuing on, what if we have to multiply? Like in our example of changing between inches and meters, right? That's a multiplicative transformation. So if we do that, that multiplicative transformation also applies to the measures of center. So your mean, median, quartiles, all of that. And it'll also apply to your measures of spread. However, it doesn't change the shape of the distribution. If it was skewed before, it's still going to be skewed now. It'll just be like stretched out more or squished together more, but it'll still be, have that same skew shape. So like going and looking at this, so here we notice that this was our original and we multiplied it by some factor. Notice it was skewed to the right before, still skewed to the right now after the factor. It's just more spread apart than it was before. Everybody kind of see that? So the spread increased by whatever that factor that we multiplied by was, as well as the center. So the means, the medians, etc. And we have that here. Okay. Let's go to that second set of in-class examples. And let's calculate the IQR for this data set. I think like a bonehead, I stopped entering these in, didn't I? What do you notice about the way this data set's arranged? Yeah, it's already sorted for us, which if you're going to do this by hand would be quite helpful, right? Boy, it's a hassle having to resort a data set. I can show you how the calculator can do that later, but for this stuff, it doesn't really matter.
We don't have that variable.
Nope. So I would have gotten the IQR to be 10. Is that what you guys get? Oh. Did I type in a data point wrong? That's not match my answer. I must have.
I got an 8.
23, 24, 6, 26, 27, 29. Ah, I missed the 29. Mr. Kulik, you dumbo. It's like that didn't match my answer key. There we go. 8 is the answer. 29 minus 21. Whew. Okay. Are there any outliers on this list?
Which one was that times 1.5?
It's IQR times 1.5. So it'd be either that much below Q1 or that much above Q3. So I'll take my Q1 and minus 1.5 times my IQR. 9. Are there any sandwiches less than 9? Nope, there's one sandwich exactly at 9, but it must be less. Must be strictly less. Now let's check above. What was the 29 was my Q3. So I do Q3 plus 1.5 times IQR, and that's 41. Do we see anything above 41 on our list? Yup! So what's my outlier? 43. Everybody's cool? Okay. What if I want that 5-number summary for this? How do I get that? Yep. We had it just a minute ago. Mr. Kulik, that's pretty annoying of you to give it to me out of order. But yep, we just go and we do our one variable stat, and it gives us to it at the end. Who can describe the overall distribution, the SOCS? Do you remember what the first S stands for?
Oh, is that like the skew?
It's the shape, yeah, either symmetric or skewed. It does look pretty symmetric to me, right? We have, if we were to plot this on a dot plot or something, it's going to look, like mostly just like a flat line or whatever. What does the O stand for? Outliers. Do we have any outliers? Yes, so we have an outlier at 43. So symmetric distribution with outlier at 43. The C is the center. So we say the center is. You could give it as the median, 26, or you could give it as the mean, 25.8 or 24.8. Since it's symmetric, either is appropriate. Everybody's okay there? Now, I would say the median is better though, because what does this distribution have that you shouldn't use a mean with? An outlier. So the median is probably your better answer there.
If there was no outlier, would the better answer be the mean?
Yes, because it's symmetric. Although if it's symmetric, they're kind of interchangeable. And then the last S stands for spread. Again, since we have an outlier, we should be using range and IQR. So you could say the range for this data set is 34. That would have been the high minus low. 43 minus 9. And the IQR was 8. I want to point out to you here, when we run our one variable statistic, remember we had standard deviation? Our symbol for standard deviation was this symbol right there where my cursor is pointing. It's the Greek letter sigma. It's the lowercase sigma. The uppercase is that big pointy E. But that's the one you want to look at on your calculator. The capital S is the sample standard deviation. We don't use that one in IB math ever. We're always going to be using the sigma standard deviation. That's the population version. Okay. Below is a list containing the number of home runs Hank Aaron hit in each of his 23 seasons playing Major League Baseball. Find the 5-number summary. So many lists on my computer. Oops. This is one where it's like punishingly, like, did you get it in your calculator correctly? You know? It's rough. Okay. Okay, so I have 23 data points in, said there's 23 seasons, so that looks pretty good. Is that what you guys get for your 5-number summary? All right, let's draw our box and whisker guy here. Okay, so we have our home runs. Now, technically, what should I still check for before I start filling this stuff in? Outliers, right? Now, I'm not going to do that right now because I am pretty positive by looking at this thing, there's no outliers. Because if I look at the low end, I have a 10, a 12, a 13. And at the high end, I have a 47, a 44, a 44, a 44, a 44. I'm quite confident there's no outlier here. But in practice, you'd want to check that first. So I'm going to build my box from 26 to 44. And I usually like to write the measurement above the thing. And then my median is the line in the middle. That's at 34. And then my whisker out to 10. And my whisker out to 47. And a lot of times I'll list, like I'll write the number above it so that particularly on something like this where the scale's pretty big, makes it easy for the reader and the person checking, right? Like if you had to draw one of these for your IB exam, I would label the lines. Everybody's cool? Pretty easy. Okay. It says use the data above to construct a table to find the variance and standard deviation of the number of students in the different classrooms. Okay, so if I wanted to do this using a table, let's do that, and then I'll show you without a table, just using your calculator, how to do this. So this is just kind of a hassle doing it this way, but it is what it is. So I've entered my data here into this list F. I'm going to need a list G. Oops. And I'm going to need another list. I guess that's I then. Oops. Let's use H. Okay. All right. So first things first, I'm going to do my one variable stat on that list G. No, F. Because I need the mean. Now here the mean is a whole number, so it wouldn't be a big deal, but I'm still going to do it like if that number is like a crazy decimal and I want to store the whole number with me, I'm going to show you what to do with that. So I'm going to go back to my table now. I'm going to move my cursor up to the column or the name for G. I'm going to press enter. And what I want to do is I want to take my observation, which would be in list F, and subtract from it that mean. To get that mean variable, I press the variables button. I go to statistics, and in the first option is the X bar. That's my mean, that's where it's stored, but I have to have run my one variable stat on that data to get that number in there. So I press enter and it populates the whole thing down for me. Ooh, that's pretty cool. And then I need to square all of these observations. So I'm going to go to the next list, go up to the title, press enter, and then I want to take that list G and square it. So I'll just pick my list G and then hit squared and hit enter, and it populates it down. And now what I want is to add up all the things in list G. So to do that, I'm going to do one variable stat on that list G. That didn't work. What happened there? Oh, I was supposed to add up list H. Mr. Kulik, you bozo. It's hard when you have this many lists floating around. All right, there we go. So what I'm interested in is the sum So you see that. Oh, actually, no, I'm not interested. I'm interested in this number. The mean is going to be my variance, because that's the sum divided by the number of observations. So that's my variance. And if I want the standard deviation, then I want to take the square root of that number. So I'll go back to the vars menu, and I'm going to grab that X bar. Now it's a new X bar because I ran a different one variable stat. So that old 24 that was in there has been replaced with that 5 point whatever there. And that would be my standard deviation. Now in practice, Mr. Kulik, couldn't I have just gotten my standard deviation by just like doing my, my normal one variable stats and gotten my 2.3 whatever? Yes. And Mr. Kulik, couldn't I have then just gone to the vars menu, statistics, pulled that value for the standard deviation, then squared it to get my variance? Yes. That's the way I'd recommend doing it, and not mucking around with a bunch of tables. But if the test question asks you to fill in the table, like you're doing it by hand, like we should show you how to do that, right? So that was a lot of calculator hoops to jump through. But again, like if you know what you're doing, you understand how the calculator works, it's not too bad. You do it once or twice and you'll remember where all the menus are at. And it's not too bad. I'm not going to do another example doing the exact same thing here. All right, so here's an example. I've given you a distribution as a dot plot and given you the statistics for that distribution. Suppose so these are test scores out of 50, right? So these are actually points for the test, not like percentages. Suppose we curved the test by 5 points. That is, we added 5 points to everybody's score. How would this affect the measures of center, spread, and location? And what would happen to the shape of the distribution? So the n stays the same, right? That's just the number of observations. What would happen to the mean?
Go up however.
Yeah, go up by 5. How about the standard deviation? Stays the same. The minimum? Good. Q1? Median? Or Q3? Max? IQR? Range? Stays the same. Because if you subtract the big minus the little, if they both went up 5, it's going to stay the same, right? Good. What's going to happen to the shape? Stays the same. How about the location? Move to the right. Because it just, everything went up by 5. Cool? What if
Good morning again, Notre Dame class. Sorry for this interruption. Just a quick reminder that we are meeting
I'm trying to listen.
and all students, you are going to report immediately to your community time room. Once everyone is in the community time room, I will start calling us down by grade levels to our Mass in the Holy Name of Mary. So we've got about 30 seconds to finish up what's going on in class and then heading to community time room.